Yeah, hi, I'm Anna. I'm a PhD student at the National Institute of Occupational Health. My thesis is about characterizing the airborne virus exposure in wastewater treatment plants, and what I will do today is to present to you some of the results I have so far. I'm not finished with my whole thesis, so yeah. I already gave you an introduction to virology and the viruses as microbial agents in occupational settings. In the wastewater, viruses can be transported from the general population during infection. And the wastewater process is generally organized very briefly with the screening section, where the trash is removed from the water, and then the sludge and the water are separated and further treated downstream. In the wastewater, we do know that we can find several harmful biological agents as viruses such as hepatitis E, rotavirus, norovirus, adenovirus. And the sewage is actually also used as a population surveillance tool for SARS-CoV-2 prevalence in the general population. The work during processes in the wastewater treatment that cause flushing, spraying, splashing, and such like that, the wastewater can be aerosolized into complex bioaerosols constituting of fungi, bacteria, viruses, endotoxin, etc., which may constitute a risk to workers' health through inhalation. We also do know that in wastewater treatment plant air, the literature shows that several viruses have been found, such as rotavirus, adenovirus, and norovirus. Workers that are working in wastewater treatment plants do have an increased risk of developing several health systems, such as soft stools, diarrhea, and also cough with phlegm. And those symptoms are correlated with working close to open stations, whereas workers working close to covered basins and workstations do not have an increased risk of developing similar symptoms compared to the control population. So the aim of my thesis is to detect and quantify airborne viruses. I'll also quantify total bacteria and endotoxin, and I want to elucidate the spatial difference between plants. So the sampling strategy I have employed so far, I visited 3 plants, all in the Oslo area. Plant A and B are the main wastewater treatment plants in Oslo, a city of 700,000 inhabitants. And they are large industrial plants built into mountain halls. And in Norway, all processes with running water has to be covered from the legislation. The samplers I've used are CIS cassettes for nucleic acid extraction, PAS6 for endotoxin and total dust, and I also used a Coriolis micro sampler. I've done my sampling trying to aim for a full workday at the grid station, sludge thickening, flocculation hall, pre-sedimentation basins, and also biological cleansing pools. And I also supplemented with point samples with the Coriolis. And I've employed personal sampling with full shift of approximately 4 to 6 hours with similar samplers. And I had access to approximately 46 workers per plant per day. And I've done the sampling both in summer and winter, but today I will show you the results of my winter samples. So the first thing I did was to look for the viruses I most expected to find from the literature and what we expected from the general prevalence in the population. So I started looking for the regular ones, right? Influenza A, adenovirus, norovirus. They cause the common cold, and adenovirus is a gastrointestinal virus as well, and norovirus cause acute diarrhea and vomiting. But in my samples, they were all below the detectional limits. So then I had to start thinking, okay, so what does this mean? Are there no viruses there, or what does it mean? Because testing for these viruses doesn't mean that no one else are present, right? So I started looking for a virus called pepper-mild mottle virus. The reason I did this is because this virus, it is not a human infectious virus, it is a plant virus. It only affects plants, but it's highly prevalent in the food we eat and is a very good indicator for, it is shedded through the feces. And it's very stably present in the sewage. is also used as a normalization for SARS-CoV-2 prevalence. So I thought if this virus is present in the air, that means that viruses are possibly aerosolized if they are present in the sewage. So I started looking for it, and as you can see, for plant A, in blue, I could find larger numbers of the peppermile mottle virus in the flocculation basins, ventilation room, which is actually the room that gathers all the air from the ventilation system and cleans it before it is released in the surrounding areas, and also in the pre-sedimentation pool. In plant B, I found the virus in the grid stations and also in the processing hall, and in plant C, I found it in the sludge treatment during flushing. But I think the most interesting for me so far was that out of the 28 samples I have analyzed so far, 24 were positive. They're below the quantification limit, but they were positive. All the personal samples were positive, and most of the stationary samples, indicating that there is a potential for exposure to viruses if they are present. So what I want to figure out now is that whether this virus can be used as an indicator for the presence of viruses. Because when it comes to bacteria, for example, if the growth conditions are present, they can multiply. Viruses can't. Either they're there or they're not. They need a host to multiply. So I want to use this virus as an indicator for viruses originated from the wastewater, which is the source of the occupational hazard here. If they're negative for this virus, I believe that the potential is low for other viruses to be present. But if they're positive and also above the quantification limit, I believe there is reason to go into further depth. So this is something I want to test out, whether this decision tree is applicable. Oh yeah, because there are some issues with a lot of issues when it comes to detection of viruses in these settings, right? You have a lot of inhibitors, etc. I also analyzed total bacteria and endotoxin. These are the total bacteria results I have from plant A and plant B. Blue are stationary samples and green are personal samples. In general, you can say that the bacterial load in both of the plants are in such a high level that it could constitute a health hazard for the workers. And you also see that the range of the data is a lot higher. There's a larger variation in plant B than plant A. Endotoxin also has some higher levels in plant B than plant A. There are actually quite large differences between these plants that are in the Oslo city. One of the things that I think is the most interesting from plant A is that the personal exposure to endotoxin is in a range from approximately 3 to 100 endotoxin units per cubic meter of air. And we did a study in 2015 where we also did a similar study, and it has since then that plant has undergone quite extensive renovation, and the exposure has decreased by a third. Whereas for plant B, the exposure has actually increased quite a lot since then. So to conclude, that I could not find any human pathogenic viruses of the ones I have tested so far. The presence of the peppermile mottle virus may indicate that other viruses may be present if they're present in the sewage, and also that viruses can be aerosolized in those settings. And the workers at plant B are exposed to a higher level of bacteria and endotoxin in the occupational air than plant A. And also, so far it seems that the bacterial exposure to bacteria may be a higher risk for these workers than viruses, but that is something I will need to go further into and investigate further. Thank you for your attention.